Can you die if light hits you? What is light? Philosophers and scientists spent millennia arguing about the nature of light. It turned out to be stranger than anyone imagined. The question of exactly what kind of thing light is dates to the beginning of modern physics. Both Descartes and Newton argued that every beam of light is really composed of tiny particles moving at high speed. The particles get emitted at the light source, like the surface of the sun or the flame of a candle, and travel along straight-line paths, except when bent by the influence of the medium through which they traveled, until they get absorbed by matter, like the retina of your eye. Now, it is important to see how different the particle concept is from the wave concept for physicists. A particle is a little chunk of stuff that can only be in one place at one time. Think bullets whizzing along a trajectory. A wave, however, is a distribution of energy that once emitted can spread out to fill space, being many places at once. Waves can also bend around objects as they travel. Bullets can only go through objects or be stopped by them. Quantum mechanics, one of the greatest revolutions in physics, began with light. As physicists built new instruments probing the ever smaller distances and timescales associated with atoms, they struggled to make sense of the interactions between matter and light. So, in a burst of creative desperation, physicists returned once again to imagining light as a particle. To explain what they saw in their atomic scale experiments, they built new models where light came in discrete bundles, little packages, or particles of light energy they called photons. But wait a minute, what about all those experiments that showed light behaved like a wave, spreading out through space and bending around objects? Physicists could not ignore them any more than they could ignore their new studies that demanded light behave like particles. Thus was born the now infamous wave-particle duality. Rather than saying light really was a particle or it really was a wave, physicists adopted a new stance. It was both, and it was neither. Wave-particle duality was the beginning of a sea change in how physics was done, forced by experiments to become far more flexible in how they viewed reality. Physicists began moving from easy-to-picture-in-your-head models to far more abstract, though still mathematically rigorous, views. Forget trying to picture what light is exactly like. That may or may not be possible. Instead, imagination was propelled beyond image, and the world was allowed to speak to us in new ways that still demanded reason in the form of mathematics but did not demand pictures. A century after the quantum revolution, we are still trying to understand what this wave-particle duality is really telling us. What we can be sure of, though, is that the world is far weirder and more interesting than that little physics laboratory in our heads. It is no accident that humans can see light. Light is our primary means of perceiving the world around us. Indeed, in a scientific context, the detection of light is a very powerful tool for probing the universe around us. As light interacts with matter, it can become altered, and by studying light that has originated or interacted with matter, many of the properties of that matter can be determined.